This is section 10.2, measuring angles and arcs. Your I can statements for this section. I can identify central angles, major arcs, minor arcs, and semicircles, and find their measures. And I can find arc lengths. A central angle is an angle that intersects a circle in 2 points and has its vertex at the center of the circle. The measure of the central angle is equal to the measure of the arc. So if we take a look at this circle, this is a central angle because it starts at the center of your circle. If angle 1 is 80 degrees, then the measure of the arc it creates is also 80 degrees. Now that's not talking about the length, it's just talking about the measure of the arc. The most common angular unit of measure is the degree, which is equivalent to 1 3/60th of a full rotation if we go counterclockwise. So the whole way around a circle is 360 degrees. When we talk about degrees, we do usually go counterclockwise around a circle. If we look at circle O, we need to find the measure of angle AOD. We need to find the measure of angle AOE. Now if you remember, a whole circle is 360 degrees around, then half of a circle is 180. So we know the top half of this circle, those 3 angles together, will add up to 180 degrees. So we know 25x plus 3x plus 2x should equal 180 degrees. Now if we combine like terms, 25 plus 3 plus 2 gives us 30x. Since we have 30x is equal to 180, and we want to get the x by itself, we will divide both sides by 30, and we'll end up with x is equal to 6. Now if we substitute this back in, the measure of angle AOD is this angle right here. So the measure of angle AOD is 25x. Since we know our x value is 6, we're going to do 25 times 6, and that'll give us 150 degrees for the measure of angle AOD. Now to find the measure of angle AOE, once again, this is a straight line, put the straight line this way. We know this is 150 degrees for angle AOD. Together they're 180. So if we do 180 minus that 150, we will be left with 30 degrees for angle AOE. An arc is a part of a circle that is defined by 2 endpoints. So this is arc AC, it's just a part of a circle. It has 2 different endpoints. When you name an arc, you do put the arc over the 2 or 3 letters, depending on how you have to name it. So our first type of arc is a minor arc. This is an arc with measure that is less than 180 degrees. Now when you name a minor arc, you can just use the 2 endpoints on the arc itself. The next type of arc is a major arc. This is an arc measure that is greater than 180. Now to know you're talking about the major arc, if I were just to name arc DE, we would be talking about this one. To know that we're talking about the major arc, you have to name the 2 endpoints and 1 point between them. So we would say arc DFE, so we know to go the long way around the circle. A semicircle is an arc that is exactly 180 degrees. Again, you're going to have to name the 2 endpoints and a point between them so you know which half of the circle we are talking about. So in circle F, we know the measure of angle DFA is 50 degrees. We know that CF and FB are perpendicular, so that means they make a 90-degree angle. And we need to find all the other measures. Now if we look, right here we have vertical angles, two lines are intersecting. Remember, vertical angles are congruent, so if this angle is 50 degrees, we also know that this angle is 50 degrees. So the measure of arc BE is 50 degrees, because remember, if it's a central angle, the measure of the arc is the same as the angle. Now if we want to find the measure of arc CBE, we're looking at this whole arc, so I need to look at this whole angle. Because I know the measure of those two angles, I can add them together, and 90 plus 50 gives me 140 degrees for those two angles together. So the measure of arc CBE is 140 degrees. Now we need to find the measure of arc ACE. Now we have 180 degrees right here because it is half a circle. So we have 180, and then we want another 50 for this part of it. 180 plus 50 gives me 230 degrees for the measure of arc ACE. Congruent arcs are just arcs that are in the same or congruent circles that have the same measure. Theorem 10.1, in congruent circles, two arcs are congruent if their central angles are the same. So if two central angles are the same, we know the measure of the arcs will also be the same. We need to refer to the circle graph. We need to find each of the measures. So we're going to find the measure of arc CD, and we're going to find the measure of arc BC. Now, in a circle graph, they give you everything as a percent. This is percent of an entire circle. And remember, a whole circle is 360 degrees. So if we look at arc CD, this piece of the circle makes up 18% of the entire circle. 18% is written as 0.18 of the whole circle. The whole circle is 360 degrees. And if we multiply those together, we're going to find the measure of arc CD is 64.8 degrees. Now we need to find measure of arc BC. BC is also 18 degrees. So since 18%, so that means they are the same. So BC would also be 64.8 degrees. Since the central angles are the same, the measures of the arcs are the same. Postulate 10.1, we kind of already used this postulate before. Arc addition postulate, two adjacent angles add up to equal the measure of the whole arc. Now we did this back when we were looking at this example. We added these pieces together to get the 140 degrees. So that was just the arc addition postulate. So this is just saying if you have two angles that are touching, we can add those angles together to find the measure of the whole arc, or add as many arcs together as we need to get the whole arc. So in this example, we're still looking at circle F. We need to find the measures of arcs AED and ADB. Let's look at AED first. AED is this arc right here. It is made up of two different angles. We have a 63-degree angle and a 90-degree angle. That last postulate just says we are allowed to add those together. So that'll give us 150 degrees for that entire angle. And remember, the central angle and the measure of the arc are the same. So the measure of arc AED is 153 degrees. If we look at arc ADB, we are looking at this whole section over here. Now remember, we can add the pieces together. If you look, we can break this arc into two parts. We have this part of the arc, which is half of a circle, and then we have the 63 degrees. Remember, half of a circle is 180. And then if we add that 63 degrees, that's going to give us 243 degrees for the angle. So the measure of the arc is 243. Next, we're going to talk about arc length. Arc length is the distance along an arc. So this is if you actually took a measuring tape and measured the distance. Remember, going all the way around a circle, distance around a circle, we're talking about circumference. So when you're finding the arc length, C is circumference, A is the angle. We can say our arc length is A over 360 times the circumference, or we can write that as A over 360 times 2 pi r, since the circumference is 2 pi r. So to think about this one, all we're going to do is we're going to figure out what part of the entire distance around. So how many degrees out of the total 360 for the entire distance around the circle are we actually covering? So we need to find the length of the intercepted arc in a circle with the given central angle measure and the radius. Now remember, to find the arc length, we're just figuring out what part of the whole 360 and then how far around it would be. The whole way around a circle is 2 pi r, and we need to figure out what part of that whole circle we are covering. So our angle is 35 degrees. It's 35 out of the whole 360. And we're figuring out how far around it. So that's 2 pi times the radius. And if we put this into our calculator just the way it is shown, we're going to do 35 over 360 times 2 times pi times our radius. And you should end up with an arc length of 2.44 centimeters. So that means if we have a circle that has a radius of 4 centimeters, and I'm just cutting off a part of that circle that is 35 degrees. We don't care about the whole distance around it, we just care about the distance on that part of the circle. So just 35 out of the 360 degrees do we care about the circumference.